A steel bar of 25 mm dia is acted upon by forces as shown in figure. What is the total elongation of the bar if the modulus of elasticity of the bar is 190 gigapascal? So this is a question of principle of superposition in which there are various forces acting on this bar. You can see here there are different forces are acting at different cross sections of the bar. The cross section area of the bar is constant and different lengths are there. Lengths of the cross sections is different, and we have to find the total elongation of the bar. So we will apply the principle of superposition in this question. So let us solve this question. In this numerical, we are given with a steel bar in which there are various forces are acting at different cross section, different sections of this bar, and we have to find out the total change in length of the bar. Basically, this is the question of principle of superposition, that different forces are acting at different section. We have to break each section and we have to find out what are the forces acting at each section, and then we have to find out the total elongation in each of the bar, and we have to sum up that using the principle of superposition, right? So here, first of all, check whether the bar is in static equilibrium or not, so that some of the forces should be equal to 0. So sigma f should be equal to 0. So F net should be equal to 0. There should be no net force in this bar, so that there is no acceleration in the bar, right? So we can see here the leftward and rightward forces should be equal, so that this will be in static equilibrium. So here, and also there should not be any couple, because there is no any inclined force, there may not be any couple. So we are checking only forces. So here 60 plus 20, 80 kilonewton leftward, 30 plus 50 rightward. So we have equal forces in left direction and right direction. So the body is in equilibrium, right? Now we have to break this bar to find out the forces in each section. We are naming this 1, 2, 3. There are 3 sections, AB, BC and CD, and what are the forces acting on each section? So let us take one section of this bar. This is one section, this is another, this is AB, this is BC, this is BC, and this is CD. So AB, BC, BC and CD, right? These are the 3 sections of the bar. And you can see here, as we have studied in theory, that there are some points which are common. This B point is common to 1 and 2. So this B point is common to 1 and 2. This is a 1, this is section 2, this is section 3. B point is common to 1 and 2. C point is also common to 2 and 3, BC and CD. So if this point is common, total load should be 20 kilonewton. Some load will be here, some load will be here, but the total load, sum of the total load should be 20 kilonewton. Also, C will be having 2 types of loads, one in BC, one in CD, but the total load should be equal to 30 kilonewton in rightward direction, right? But A and D has no common point. So at A the point is 60 kilonewton, so the force will remain 60 kilonewton, and here also the force will remain 50 kilonewton. So here we can safely write that force is 60 kilonewton. And if it is 60 kilonewton, there should be a force in this direction, so that the body should be in static equilibrium. So this is also 60 kilonewton. And D also have 50 kilonewton, and it is not going to change. So this is 50 kilonewton, and for static equilibrium there must be 50 kilonewton load in leftward direction. So we have got the forces in 1 and 3, that in 1 the tensile load is there 60 kilonewton, in 3 there is tensile load is there 50 kilonewton. What is the load on 2? You can see here that at B 60 kilonewton is rightward. So if we apply 80 kilonewton leftward, then there will be 80 minus 60, 20 kilonewton leftward. So we can apply 80 kilonewton leftward leftward, so that we could get the sum of these two becomes 20 kilonewton leftward, right? So at B we can write force on B, we can write 60 kilonewton rightward plus 80 kilonewton leftward. This is positive, this is negative, so it will become minus 20 basically. So it will become 20 leftward, 20 kilonewton leftward, which is the case, which is actually our the force on FB. So this is the check that whether we have done correct or not. So this is 20 kilonewton leftward total load which is there, right? We can also check here that at C the total load, the load applied is, if it is 80 it must be 80, so 80 is rightward, 50 is leftward, so 80 rightward, 50 leftward, the sum of the two will be 30 rightward, so this will be equal to 30 kilonewton rightward. Is it correct or not? Please check. 30 kilonewton rightward, so 30 kilonewton rightward, that is okay. It means we have applied the correct forces, right? So the forces are, all the forces are tensile. AB tensile force is 60 kilonewton, BC tensile force 80 kilonewton, CD tensile load 50 kilonewton, right? Apply the principle of superposition that delta L must be equal to delta L in 1 plus delta L in 2 plus delta L in 3. So we can apply this formula and we can find out the value of total change in length of the bar. There is elongation of the bar, change in length, increase in length of the bar, because all are tensile, right? So we can use for tensile the positive sign convention, and for compressive we can use the negative sign, right? So what will be delta L? So delta L will be equal to, delta L must be equal to PL upon AE. P load, we can use this formula PL upon AE for each section. So P, and the area, what about area? Area is dia is given 25 mm, right? So we can apply the formula directly. P is the load in this P1, right? So you can write P1 is basically 60 kilonewton, P2 is 80 kilonewton, and P3 is 50 kilonewton, right? So these are the loads. So we can apply PL upon AE. P is 60 for kilonewton 10 power 3 multiplied by L. L is given in meter, you can apply in millimeter, so that answer may come in millimeter, right? So you can apply 2000, so that answer should come in millimeter, because the extension are very small, generally used, all the deformations are in mm, so we are using mm for length also, right? Other things will remain in SI unit. So area is pi by 4 d square. So pi by 4 d square, d is 0.025 square, multiplied by E. E for the steel is given 190 gigapascal. For giga, take 10 power 9. So this is the first term. Next term is 80 kilonewton. So you can write 80 kilonewton. So 80 kilonewton multiplied by length in millimeter, 1000 millimeter, divided by area, pi by 4, area is same, so you can use 0.025 square, multiplied by E is again same steel material is there, 190 gigapascal, giga is 10 power 9, plus third section 50 kilonewton, so you can write 50 multiplied by kilo Newton, so kilo 1000, and length is 3000 divided by area is pi by 4 d square, 0.025 square, and E is 190 gigapascal. So these are the three terms. Add these terms using calculator. Take your time and calculate it. I hope that you have calculated the value. Finally I am writing here, which will come out to be, that will be 3.75 millimeter. So this will be the answer. 3.75 mm.